Okay, so we have the state table here, and we have to draw we have to draw an FSM, a state table, a state assigned table, and the circuit to represent this state table. So let's start off with writing an FSM. So we'll start off at present state A, and we see when we're at A, there's an output called output of Z equals 0. Now when we see if W was 0, we go back to state A, but if W was 1, we go to state B. And when we're in state B, we look at this side and we see the output should be 0. When we press W equals 0, we go to state A, so we go back to state A. But if you press W equals 1, sorry, this W equals 1 is for state A. I forgot to include that. But hold on, sorry, this should be state B. Sorry, I wrote A here, my bad. So when we press W equals 1 when we're in state B, we go to state C. And then when we're at state C, our output is 1. Okay, and then when we're at state C, if we press W equals 0, we go to state A. And then if we press W equals 1, we go back to state C. Okay, so that's the FSM diagram. Oh wait, there should be a W equals 1 here. There we go. Okay, and so pretty much the job is this a Mealy or Moore machine? So this is a Moore machine because the outputs are only dependent on the state we're currently sitting in. Okay, if let's say in the state table there was something like this, W equals 0, W equals 1, and then there was like a few zeros here, and then like a few zeros here, ones or zeros here, then this would be a Mealy machine because the output depends on our state as well as what our input is. Okay, so W is pretty much supposed to be our input. Now we're going to draw a state assigned table. So we're going to represent these everything as ones and zeros. So we'll have present state. Hold on. So we have present state, next state, and then output. So this side will be W equals 0, W equals 1. So next state we're going to represent using uppercase Y's, so uppercase Y2, uppercase Y1, for W equals 0, W equals 1. Our output will only represent it as Z, and our present state will represent it as lowercase y2, lowercase y1. So AA will be represented by 2 zeros. B will be represented by 0, 1. C will be represented by 1, 0. Okay, so when W is 0, it's all 0, 0, 0, 0 because 0, 0 is A. Okay, so this one it's going to be B, so it's going to be 0, 1, and the last two are supposed to be C, so it'll be 1, 0. And then output is just how regularly it was. We should also add a fourth column called 1, 1, and we're gonna split as don't care. The reason we're doing this is because we have to find a formula to represent uppercase Y2, uppercase Y1, and our output. And obviously, we're gonna use a K-map. So, but the K-map is gonna have a section called 1, 1, and obviously we need to find the place to represent 1, 1 as something. So here, let's start the K-map. So this K-map will be for Y1. Okay, so here the input is going to be W, and then up here the inputs are going to be Y2 and Y1. So it's going to be 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. So right now, only pay attention to these columns. Okay, oh, yeah, and then this as well. So for when W is 0, so we're going to be focusing on this column because it's the W equals 0 column for Y1. We compare it with these values. So for 0, 0, uppercase Y1 is 0, so we'll put that here. For 0, 1, it's 0. For 1, 0, it's 0. and for 1 1 it's don't care. Okay, now for the other one, for when W is 1, for 0 0 it's a 1, for 0 1 it's 0, for 1 0 it's 0, and for 1 1 it's don't care. Okay, so that means we're just going to circle this one, and the function we get from here is going to be our y1. So it's going to be W y2 naught y1 naught. So y1 is going to be equal to W y2 naught y1 naught. So now we're going to do y2. So W1 goes here, sorry, W goes here, and it's y2 y1. Okay, so back here we're only going to pay attention to the y2 uppercase y2 columns. Hold on, sorry. Oh wait, oops, sorry, ignore that. Okay, so it's these ones. So we see when W is 0, which will be this one. For 0 0, y2 is 0. For 0 1, it's 0. For 1 0, it's 0. And for 1 1, it's don't care. For when W is 1, when it's 0 0, it's 0. When it's 0 1, it's 1. When it's 1 0, it's 1. And when it's 1 1, it's don't care. So we can, for this one, we can group them in this way. And so y2 will be, let's see, it'll be W y1 plus W y2. All right, there we go. So that's for y2. Now the last one is z, and z we can kind of see spot on that z and y2 are equal to each other. So we didn't even have to do a K-map. We can just say z is equal to y2. Now we can draw a circuit using all of this. So circuit will start off by putting 2 D flip-flops. Okay, so whatever is entering the D flip-flops, they're supposed to be your uppercase Y values, and what's leaving your D flip-flops, they're supposed to represent your lowercase y values. So we'll have y2 represent this, and y1 represent this. Okay, so that means that's what's entering here is going to be uppercase y2, and what's entering here is going to be uppercase y1. So let's see, let's do y1. So we need to have an input called W, and we'll put a AND gate. We'll take the NOT of W2, feed it into this AND gate, and the NOT of W1 and feed it into this AND gate. And then we'll connect it to here. So the output at this region will be W, Y2 NOT, Y1 NOT. Now for Y2, we need to make a function like this. So what we can do is, let's see what we can do. We can have 2 gates like this, put 2 inputs here, and take y2 and take y1. Okay, let me redraw that. Hold on, take y1. Okay, then we can use OR gate to combine them, and then connect it to this.